Today we will discuss for a derivation. Question is, obtain an expression for the capacity of a parallel plate condenser when there is a partially air and partially a dielectric medium between its plate. Or question can be another type like establish the formula for capacitance of parallel plate capacitor in presence of partially dielectric medium. Okay. Now let's make two parallel plate X and Y like this and put a dielectric medium with constant K inside it. Thickness should be considered T and the distance between two plates, let it be small d. Surface area of every plate we, we should consider capital A. Now the explaining. In figure, the distance between the plate is d and in between the plate there is a dielectric medium of thickness T and dielectric constant K. Now the plate X is given by plus Q charge. The positive charge will be in the surface of plate AX and induced negative charge on the plate Y, and all the induced positive charge on the outer side of plate Y go to vanish. I mean to say that charge will neutralize due to earth, due to coming electron from earth. So now put a point, take a point P inside the parallel plate in the presence of air. Then due to plate X there is a electric field intensity Ex. Directions will be from plate X to plate Y in this direction, and due to plate Y intensity field, electric field intensity Ey, direction also from X plate to Y. So first of all we will find out the intensity of electric field intensity on air, and similarly after that we will find out the electric field intensity on inside the dielectric medium, let it be Pt. Due to plate Ex, that will be Et, Ext and Eyt. Okay. Now remember the metric for for a plate, एक for a long plate like infinity shape, due to long plane plate, the electric field intensity at a point is equal to E is equal to charge by area of surface area of plate A and 2 times of epsilon 0 and dielectric constant. This is our key point. This is our formula for solving this derivation. Okay. Now due to plate X electric field intensity Ex will be Q upon 2 epsilon 0 Ka. and due to plate EY plate due to plate Y, electric field intensity EY will be, because there is a minus Q charge on plate Y. Due to charge of plate Y, the electric field intensity EY will be Q upon 2 epsilon 0 Ka. Resultant electric field intensity on point P will be resultant electric field intensity E A for air, EA is equal to EX, sum of these EX and EY. We get EA A for air is equal to, put value of EX and value of VY, we get Q2 epsilon 0 Ka plus Q upon 2K epsilon 0A is equal to 2Q 2 epsilon 0 Ka, 2 cancel. Finally, we get electric field EA A for air is equal to Q upon K epsilon 0 A. Put a number 1, equation 1, right? Similarly, we will solve the electric field intensity inside the dielectric medium. We assume that there is a point Pt due to plate X at point Pt, electric field intensity will be, let it be, Ext is equal to, copy this formula, Q upon 2 epsilon 0 Ka. Due to plate Y at point Pt, electric field intensity EYT is equal to Q upon 2 epsilon 0 Ka. Finally, resultant electric field intensity inside plate dielectric medium material inside ET will be Ext plus EYT. We get ET, put the value of Ext and EYT from these, Q upon 2 epsilon 0 Ka plus 2 Q 2 epsilon 0 Ka is equal to, both are same, then 2Q upon 2 epsilon 0 Ka. We get Et is equal to Q upon K epsilon 0 A. Now look, both equation 1 and 2 are looking same, because now put proper value of constant, dielectric medium constant and air constant. So we know that medium of dielectric constant, medium of dielectric constant for air, K is equal to 1. Then from equation 1 we get EA, electric field intensity for air, is equal to Q upon epsilon 0 A. This will be equation 3. And for material having partially a dielectric medium, for partially filled dielectric medium constant is K. Then from equation 2 we get ET, electric field intensity for thickness of dielectric medium, that is ET, is equal to, put the value of K is equal to K, that is K epsilon 0 A, given number 4. Now we will find out the potential difference between two plates, that is X and Y. Now potential difference is equal to electric field intensity multiplied by distance of two plates. But in this case there is a partially filled dielectric medium, that means the distance which is filled by dielectric medium, that is T, thickness. So the air filled the distance between two plates with air, that is D minus T. Look here, V is equal to, this formula will be put up for both for dielectric medium and for air. For air, the distance, electric field intensity for air, that is EA. EA will be multiplied by distance for air, that is D minus T. Because look here the figure, because total distance from X plate to Y, that is D, that means the air is filled in the total length, that is this and this. That means to subtract distance T from D, that means the air is the distance with air, that is D minus T, that is D minus T. Then EA will be multiplied by D minus T plus the distance, that means the thickness of dielectric medium, that is T, will be multiplied by ET, electric field density inside the dielectric medium, partially filled, that is ET multiplied by T. Now put the value of EA and ET, from this we get V is equal to Q epsilon 0 A d minus t plus Q upon K epsilon 0 A t. Now take common from both the term Q upon epsilon 0 A, Q upon epsilon 0 A. Take common Q epsilon 0 A inside bracket plus T upon K. Simply by from formula of condenser, that is C is equal to Q upon V. Put the value of V from this formula. We get C is equal to Q upon, this is numerator, the whole quantity is in numerator except epsilon 0 A, Q d minus T, plus T upon K upon epsilon 0 A. This will be go to the numerator in next step. Just a minute, page going short. C is equal to Q, this going to numerator, epsilon 0 A upon Q bracket d minus T plus T upon K. These are cancelled. C is equal to epsilon 0 A upon d minus T plus T upon K farad. This is our desired derivation. I hope you understand. Then okay, good luck.